Whether you are trekking on Sahara Desert or scrambling on Mount Everest or you are on a field mapping project, there is always a fear of getting lost. And to be a fearless explorer, you need a good sense of direction. Hi, I'm Sumit, here to feed your curiosity on Meridians and Bearings. In this video, we will talk about what is meridian and what are different types of meridian, what is bearing and what are different types of bearing, and the different systems to note bearing. So let's get started.
You have been assigned to a mapping program, and one day you decide to go on a field trip. You reach the field and set up your camp. Now you walk few distance from your camp, looking for a permanent physical feature. Walking a few meters away, you reached a point from where you can see a lighthouse. Now you decide to use it as a reference point for all of your observations, and the location where you are standing as the base station. Now you have 3 points: the base station O, the lighthouse L, and the camp C. Now we have the angle LOC, which will be a horizontal angle, as all the lines are drawn on the eye level. Now let's measure the angle LOC by taking the line OL as the reference line, as already decided. So we will place the protractor 0 degree at the OL line and will measure the angle LOC, which is 70 degree. So we can say that the bearing of the line OC is 70 degree moving clockwise from the reference line OL.
Now, bearing of a line is a horizontal angle that it makes with a predefined line of reference, also known as a meridian.
The last example you saw is example of a arbitrary meridian, as we have chosen a arbitrary line OL for all our observations.
A arbitrary meridian may vary with time, space, and convenience of the observer. This can help you in finding relative sense of directions, and only helpful when small-scale surveys are involved. But in case of large-scale surveys, you need an absolute sense of direction, which is accepted by all and easy to figure out.
Earth rotates around an imaginary axis of rotation. This imaginary line intersects the surface of the Earth at two locations, known as true north and true south, otherwise known as geographic north or geographic south. Now the question is, what is true meridian? True meridian is the line connecting the true north to south pole along the curvature of the earth. Thus, true bearing of a line is the horizontal angle that it makes with the true meridian. Let's take this example. You are standing at the point O and you want to find out the true bearing of the line OC. Thus, you took the true north line as a reference line. Now placing the protractor, you found out that the line OC makes 70 degree with the line north, and hence the true bearing of the line will be north 70 degree east. But wait, it's not the end. Our earth acts as a bar magnet, thus having two more poles, one magnetic north pole and magnetic south pole, and this differs from the true north and true south. And having magnetic pole, we have magnetic meridian, which is defined by the lines connecting the magnetic north pole to south pole along the magnetic flux line at any point on the surface of the earth. Thus the magnetic bearing of a line is the horizontal angle that it makes with a magnetic meridian. Till now, we have covered what is arbitrary meridian and arbitrary bearing, true meridian and true bearing, and magnetic meridian and magnetic bearing. While arbitrary meridian depends upon the convenience of the observer, establishing true meridian needs celestial observation. But the magnetic meridian only needs a simple magnetic compass to establish it. Thus, it becomes the most convenient way of measuring a bearing. While noting bearing, it can be read in three ways. Let's say we have 2 points O and A. So looking towards A from point O, the bearing can be read as bearing of line OA, shown as an ray OA, which shows the direction where we are looking. Or it can be represented as bearing of A from O, or it can also be represented as bearing O to A. There are two common systems of notation of bearings. One is the whole circle bearing or the azimuthal system, Another is the quadrantal bearing or known as reduced bearing system. In case of a whole circle bearing system, as the name suggests, it is based on a 360-degree clockwise circle. The bearing of a line is measured from north in a clockwise direction, and all the angles varies between 0 to 360 degree. In case of the quadrant bearing system, as the name suggests, the circle is divided into 4 quadrants of each 90 degree. In this system, the bearing of a line is measured eastward or westward from the north or south, whichever is nearer. Thus, both north and south are used as reference meridian, and the direction can be either clockwise or anti-clockwise, depending upon the position of the line in the system. Let's take an example for better understanding. Imagine the situation as shown in the picture. Suppose you are standing at point O and you are looking for the bearing of A, B, C and D around you. As we know, for taking bearing measurements, we need to establish any meridian at point O. Let's first establish that. You used your magnetic compass and found out the 4 cardinal directions, north, south, east and west, and you plotted that at that point. Now it's time for noting the bearing of these lines. Let's take the example of line OA. In azimuthal system, we take all measurements from north and go clockwise. As you can see in the picture, going clockwise from north, the line OA makes 48 degree with north. Thus, bearing of the line OA will be 48 degree. We will write it as 048 degree. Let's take the same measurement in quadrant bearing. In case of quadrant bearing, while taking measurements of bearing, we have to consider in which quadrant the line lies. In case of the line OA, it lies in the northeastern quadrant. That's why it will be near to the north cardinal point. Thus, moving clockwise from north, it gives 48 degree. So, we will write this as the angle 48 degree sandwiched between the letter N and E. The bearing of the line OA will be read as 48 degree east of north. Similarly, the line OB makes 130 degree moving clockwise from north. Thus, the bearing of the line OB will be 130 degree in azimuthal system of bearing. Now, the line lies in the southeastern quadrant, and in case of a quadrant bearing system, it will be measured from south in an anti-clockwise manner towards east. So, the bearing of B from O will be 50 degree east of south. Similarly, the bearing of C from O will be 215 degree in azimuthal system and 35 degree west of south in quadrant bearing. So, bearing of O to D will be 323 degree moving clockwise from north in azimuth system, while the quadrant bearing will be 37 degree west of north moving anti-clockwise from the north direction.
I hope now you have a good sense of direction. Now you can be fearless. Before end of this video, it's time to feed your curiosity. Let me know in the comment section below which meridian is a constant quantity that doesn't change with time, space or convenience of the observer.
If you find this video helpful, then like, subscribe and click on the bell icon for more such updates.